Welcome to the Art of the Possible series. I'm Nihalini Yogi, and I'm a Principal Cloud Solution Architect at Microsoft. Of course, we cannot start anything these days without saying the word AI. So I asked ChatGPT to welcome my guests. Let's see what it has to say. So here we are in AI Studio. I'm in the chat playground, and we're chatting. And of course, we are using the GPT-4o mini model. And I gave this a prompt. I said, you are a funny and a helpful network architect with good sense of humor. You're from Boston. You're knowledgeable about Azure networking. So let's see. We'll ask it to welcome our guests. So, and one more prompt. Tell me a network engineer joke. And there, off we go.
Can you tell us the joke with a Bostonian accent, Nihali?
I'll try. So back to the normal me now that we've seen this. Now that we have ticked the AI checkbox, back to the real me without the Boston accent. So again, welcome everyone. Today's session is a kickoff session for a playlist on integrated NVAs, network virtual appliances, and SaaS solutions in vWAN. And this video will be followed by a series of sessions with individual partners. Today's session is very special for me. Coming from data center networking and security background, I have worked with a lot of third-party firewalls, routers over the years, and of course, who could forget those 2 a.m. cutovers, right? So I have to be honest, when I joined Microsoft about 4 years ago, I couldn't have imagined I would have this opportunity to work with the top networking partners and professionals in the industry. And I'm very, very grateful for this opportunity. I want to give a large shout out to Cynthia, my accomplice for this series, from idea to execution, and the growth mindset and energy she brings to the table every day. I also want to recognize two of my guest speakers today, Maze and Shruti, who are an inspiration to me, and want to thank each one of my peers across broader Microsoft who have joined this session and always being available to bounce off ideas, questions, and creating a culture of learning. Let's do a round of introductions. We'll start with Cynthia, and then we can just go down the alphabetical order. Cynthia, over to you.
Yeah, thanks, Nihali, and hi, everyone. So I'm Cynthia. I'm based in France, and like some of the persons on this call, I'm a networking GBB. So we are a global team of technical pre-sales consultants focused on Azure networking. I've personally joined Microsoft and the Black Belt team 2 years ago, and before that, spent almost 20 years in the telco industry. During my time there, I was working for a service provider and covered many different roles, including like MPLS backbone design, customer migration and support, SME. And finally, after 15 years of being a config engineer, I switched to sales engineer. And it's also at that point that the move to cloud was something that we heard more and more often, and that became a common requirement in every customer RFP. And it was also around that time that SD-WAN and the internet-first approach grew in popularity. And I had the chance to design some really fun architectures for these transitions. And that's how I started to explore what was going on in Azure as well. And so here I am now with I think my brain almost rewired from traditional networking to cloud networking. And yeah, super excited to run the session with to run the networking series with Nihali. It's been great collaborating with her on that, and to get the support of all the like fantastic minds we have in this room, in this virtual room. Thank you.
Let's start with Martin. Please introduce yourself.
Sure, yeah. I am Martin Twombly. I'm a cloud solutions architect and Azure Alliance lead at Fortinet. I've been at Fortinet for about 10 years. Yeah, just over 10 years now. In this role or very similar roles since I started. I started right around the time the ARM version of Azure was launching and started integrating Fortinet products and working with Microsoft developers as well as Fortinet developers to try to bring security solutions into the Azure marketplace. Been doing similar things ever since.
Nice. Welcome.
Having you.
John, you want to go next?
Hi, everybody. My name is John. I'm a Cloud Alliance architect from Checkpoint. Been with Checkpoint for 10 years as well, like same as Martin, 10 years at Checkpoint. First half of my career at Checkpoint, I was the SE director out of North Asia. Since then, moved back to Seattle, Washington. I've been in this role looking after the Microsoft and Checkpoint integrations for the past 5 years. Roughly about 20 years of networking experience. Working with various different vendors, like firewall vendors, and then end up at Checkpoint here. So thank you for having me. It's great to be here, and thank you for the opportunity. So that's me. Nice to meet everybody here.
Welcome. Yeah, Juan, I think you're up next.
Can you guys hear me?
Yes.
Very well, thank you. Hello, everyone. My name is Juan Sterbank. I'm a Cisco networking solutions engineer. Been with the company for a little bit more than 10 years. Started off my career covering service provider accounts, MPLS designs, things of that nature. And then I switched gears to the cloud division group. Back then it was Cisco Meraki, basically the cloud managed enterprise networking solution that Cisco offers. And starting this year, we now basically cover the entire enterprise networking portfolio, which includes Cisco Meraki and Cisco Catalyst. I have also been specializing in the public cloud integrations that our company offers, particularly in Azure. So yeah, it's certainly been quite fun, quite a great experience. So nice to meet you all.
Thank you, Juan. Anton?
Hi, everyone. My name is Anton Budulowski. I'm with Palo Alto Networks. I'm a technical architect on the Alliances team. I've been focusing on our partnership with Microsoft for the past 2 years. I was part of the product team that launched Palo Alto SaaS offering in Azure. My background is also just like Cynthia's IP/MPLS networking. I worked for a vendor, network management, IP/MPLS networking, wireless, pretty much SD-WAN when it came around, data center SDN. I did a short stint at a colo provider as well, somehow I ended up in cybersecurity, but I'm still doing networking, so you can't escape. Good to meet everyone.
Thanks, everyone. And I'm going to have Maze and Shruti, you guys introduce yourself as well, since you're the guest speaker on the panel. Maze, you go first.
Thanks, Nihali. So my name is Maze Al-Jabari, and I have been with Microsoft for 5 years. I started as a support engineer and then technical advisor, and then moved to same team as Cynthia, Global Black Belt team, or specialized in networking and network security, and I'm covering the US regions. Thank you.
Awesome. Thanks, Maze. Shruti?
My name is Shruti, and I'm part of the advanced networking team here with Microsoft, same as Maze and Cynthia. I've been with Microsoft for about 7 years, with GBB team for 2. And I think this is a great opportunity. Thank you, Nihali, Cynthia, for giving us an opportunity to talk about the SME presentation today. Thank you.
Thanks, Shruti. Yeah, look forward to that. Just a quick overview of my screen for those of you who are new to it. What you see on my screen is a Draw.io based tool that I use for layered and reusable diagrams. So the tool is called Draw.io, and over the course of this video, you will see me navigating these layers, which help clarify some of the complex flows. And then, of course, this is the tab that is in question. Okay, and then this series is the foundational element of this series is, layered and reusable diagrams, and of course, keeping a growth mindset. So, if new designs come up, if there is a more optimal way to solve a solution, do let us know. And if you are another vendor and would like to present on this, do let us know as well. So with that, I'm going to run through, Cynthia and I are going to run through scenarios that are common that we see in the field. And of course, we start with the base scenario, and then we kind of go into the more complex one. As new features get rolled out, we go into scenarios with integrated partner NVAs as well. So what you see on my screen is a multi-region vWAN architecture. And the default scenario, as you could see, introduced a hub router here, a vHUB. And the default flows are, if you see here, the green flows are the spoke to spoke and branch to spoke flows that work out of the box. And then, of course, the purple ones are the branch to branch. That's in region 1. And likewise, you can see in region 2, all of the working flows are shown. This is what we call it any-to-any connectivity, out of the box, network as a service. This is a classic use case for IP routing, basic routing working. This does not include the inspection capabilities. And of course, the outbound for outbound, it uses the default NET capabilities. And just kind of complete the flows. I'm going to hide some of them for clarity. If you want to look at interregion flows, this is what is all supported. So this is kind of shows you a full picture of all flows, any-to-any connectivity. And then just want to call out a couple of routing considerations over here that, express route connected branch to another express route connected branch goes through global reach. Cynthia, anything you would like to add? Anything I missed here?
I think you've covered it well. And yeah, here really the important point is that with Virtual WAN, by default, we get that full mesh, that any-to-any connectivity without any additional configuration required. And about the branch-to-branch you've mentioned, so that's settings that is enabled by default at the Virtual WAN resource level, which enables site-to-site to express route, for example. But this is something that can be deactivated if needed.
Right. Thanks, Cynthia. Yeah, and SD-WAN integration isn't yet shown in this diagram, but we will get to it as we progress through the scenarios. And Cynthia, I am not able to see the hand raise, so if there is any, you do let me know.
No, you can go ahead.
Okay, thank you. That brings us to the next scenario, which is secured vWAN hub, no routing intent. This is native vWAN security for private and internet traffic using Firewall Manager, no third-party integrations. Since we have a few security partners on the call, just want to highlight that for partner integrations, you do need routing intent, which I will be covering in the next scenario. Again, this is secured vWAN hub, no routing intent. Now let's look at all the flows. Let's start with the north-south flows here. And as you can see, you can, of course, advertise quads 0 downstream, and these sites can reach the internet through Azure. Of course, I'm missing a flow over here from Spoke. You can also egress through this firewall. And now let's look at the spoke to spoke flows. These spoke 1 connect talking to spoke 2 through the firewall, and anything from branch to the spoke traverses the firewall as well. Going to the next layer, branch to branch, local branch to branch bypasses the firewall. Let's look at interregional flows. Interregional flows are not supported. So you can see that traffic initiated from this branch going to the spoke, the return traffic will go follow the default route and hit the firewall, and that's where it will get asymmetric. Similarly, these are interregional flows not supported, traffic will get it asymmetric. So let me highlight all the flows that are not supported. And let's look at the potential solution, right? So this sets up the stage for routing intent. So let's look at the potential solutions. The first solution is routing intent feature, like I mentioned earlier, and you can use integrated NVAs with it. Tiered vNET design, Cynthia is going to go into the details of that. And then finally, there is a workaround we will cover with express route bow tie design. Anything else you would like to add, Cynthia?
Maybe just recap why we would be using a secured hub without routing intent. That's because at some point routing intent was not available, but we could have individual secured hub. And as you mentioned, yeah, with that design, we don't have inter-region inspection, and we don't have branch-to-branch inspection capabilities. So this is not supported with this kind of design. And back to the workaround, I mean, this was something, this was still a design that could be interesting for some customers who were not really in a need of having inter-region connectivity, but who were looking for having a dynamic hub and spoke topology with inspection, because by default, vNET to vNET connectivity is enabled, and you get that central inspection in the hub as well. So not very common, but still, you know, it had it was used by some customers. And to bypass the current unsupported inter-region flows, as represented on the screen, we could use here bow tie and the express route hairpinning, we call it, and that means going down from one hub via express route up to the MSE, down to the MSE, and using an express route connection to the remote hub, enter the remote hub via, you know, express route and go up to the spokes. This way we could have inspection, so inter-region inspection. But again, this requires the use of the hairpin, which is not recommended anymore, and to have the right hub routing preference set as well. Quickly, why the hairpinning is not a recommended solution? It's because it's for basically performance and latency reasons, because obviously traffic is going down to the peering location, which is different from the Azure region, and up to another Azure region. And also it adds bandwidth consumption on the existing express route circuit that is usually set up to provide hybrid connectivity from on-prem.
Thanks, Cynthia. Great points. Yeah, so again, like Cynthia mentioned, really routing intent is the way to solve this, you know, the flows that we are displaying here. And then, of course, the tiered vNET design. And the third option with the express route bow tie is mostly a workaround. And just to summarize this, and you know, if you are using this diagrams for your sessions, we do have you know, presenters notes over here, like to highlight, like Cynthia mentioned, no inter-region inspection and no branch to branch inspection in this secured vWAN hub design. Okay, so I think we're ready to move on to the next layer here.
Neali,
Yes.
I think we have a question, or I think a hand raised.
I think John has a question.
Yeah, so I just have a quick question in regards to the multi-region express route design. Is that a common practice with the bow tie express route to each region? Is this a common design pattern that Microsoft recommend customers to deploy, or this is specific for the use case that we're talking about with the firewall?
So clearly not a recommended design. I think this design came about when we didn't have some of the routing intent features GA'd and things like that. But
Gotcha.
Cynthia, you want to add something, add more to it?
Yeah, I think a lot of questions are coming from the fact that if we go back to that previous to this design, is that here we are not presenting routing intent. We are presenting secured hub, what we call secured hub, because we put an Azure firewall basically inside the hub, but it's not
Gotcha.
working like inter-region, etc. The feature where we have inter-region, full inspection, etc., that is called routing intent. But here we are not yet in the routing intent context.
Okay, gotcha. It's just that I have a design very similar, to the bow tie design with another customer right now. But we can discuss that offline. I think this is where this will come in place and help us with some of the regional failover capabilities. So
yeah, sure.
So okay, thank you.
Yeah, Anton has a question as well.
Yeah,
Yes.
just a follow-up to this discussion. So this design with no routing intent, what would be like the determinant factor, like the customer actively, not looking to use routing intent? Is there a use case where like they want to use custom routing tables, they have some sort of corner case where routing intent will not work for a customer and they would go with this design? Like, do you see those out there in your discussions with customers?
Yeah, exactly. So that's typically the use case. So I have a customer using secured hub, but not routing intent because they're using custom route table to, for different reasons. And so they had to configure granularity in the inspection for some flows and no inspection for some others. And also because inter-region was not like mandatory for them, so they prefer to not switch to routing intent, but keep that granularity per region and still having the ability to use the central solution in the hub and the direct vNET to vNET connectivity.
Yeah, thanks, Cynthia.
Yeah, so now I think that this sets up the stage perfectly for routing intent. So notice that, just want to call this out, that in secured vWAN, we kind of have the firewall kind of off to the side, and with routing intent, we have this icon that shows the routing intent is enabled. So with routing intent, we get all of the flows, including north-south or internet-bound flows going through the firewall, and then of course the private traffic or east-west traffic all traversing the firewall. So this looks very, very similar to what we saw with any-to-any sort of the IP routing, except and in this case we also add the inspection capabilities. And likewise, inter-hub, let me hide some of the other flows. The inter-hub traffic traverses the firewall twice. Right, so those are all of the flows now are supported with routing intent. Everything funnels through the firewall, and some of the routing considerations is that in the event that you do want to inspect subnet to subnet traffic through the firewall, you would need to add a UDR at the subnet level. And anything, and here just want to call out that for the internet bound traffic, it is local breakout only for internet, right? So these folks will reach the internet through this local firewall, and likewise on this region. Cynthia, anything else I missed or you would like to add?
Sorry, I was muted. Yeah. So just to add on the internet connectivity you've mentioned. So yeah, the internet connection, internet outbound is local to a region. So the 00 won't propagate inter-region from one hub to another. That's an important point. And to get the default route from the security solution in the hub advertised to on-prem, you need to explicitly enable default route propagation to the branches, because by default it's not enabled. So it's something really easy to enable, but you need to think of doing it if you want that connectivity to happen. And maybe just to highlight again that in routing intent, there are two types of protection. We have private traffic protection and internet protection, and you could use either one of them or both together, depending on what you want to use the firewall in the hub for.
Great point, Cynthia. And no custom route table, right? That's another consideration for this design.
Exactly. Yeah.
Right. Looks like Juan has a question. Juan?
Yeah, so can you go back to that section where you show how to have an inspection for spoke-to-spoke communications, where you needed to add an UDR?
Oh, yes, sure.
Yeah.
Routing considerations, yes. Yep.
There we go, that one. Out of curiosity, because I'm pretty sure I saw this when doing some testings. When you add that UDR, what I've also seen is that if you have resources inside the same vNet, let's say 2 virtual machines, and you add that UDR, flows between those 2 virtual machines will also go through, the v1 hub in this case. Do you know if that's the desired outcome? Would that happen or not?
That's a good point. You're talking about host-to-host communication between
Yes.
I think I'm sorry to put you on spot, John, but isn't that something we tested with Checkpoint? I just want to make sure that was the desired behavior, or that was like a side effect of that. I'm trying to remember.
So the first thing I want to clarify, yes, the host-to-host is possible. So, traditionally 2 hosts within the same subnet, you'll go direct. But with the UDR in place, you can send the traffic within the same subnet, host to host, have that route to the firewall in the hub with the routing intent. Oh, sorry, with the UDR. And the only catch is you need to send that traffic to the internal load balancer. At least for the Checkpoint solution, right? And then in this case, subnet, host to host, that you require UDR. Did that answer your question?
It does, yes. Thank you.
Okay, cool.
Thank you, John. I just remembered we had talked about that before. Excellent. Anything else? Nope. So with that, so far we've covered 3 of more what I call it native sort of solutions, and now we're going to go into more indirect spoke model and scenarios with virtual appliances. With that, I'm going to turn it over to you, Cynthia, for this use case.
Yeah, thank you, Nehali. We've gone through virtual WAN with standard hubs without any security solution, and now today we have routing intent. But before routing intent was available, customers still wanted to have a way to secure their traffic in Azure. And a very common design before that, but still relevant today, and we will see why, was what we call the indirect spoke model, or the tiered vNet architecture, because the spokes are not attached directly to the vHUB anymore, but are cascaded behind the transit vNet that contains the firewall solution. So I'm talking about firewall solution because it could be an Azure firewall or any other third-party NVA your customer would like to work with. So this goes above the managed offer we have with some vendors in the vHUB. Any NVA could be deployed in that hub. And because it's not in the virtual, in that transit vNet, and because it's not in the virtual hub anymore, because it's not a managed offer anymore, there is full control of the NVA deployment. So in terms of scaling, there could be any number of backend instances for that solution, and also some features are missing or not available in the managed offers in the virtual hub, and so customer may still, for example, want to build VPN tunnels towards this firewall. This today is not supported for managed NVAs, also in preview for some of the solutions, as we will see in another episode. But yeah, so for all these reasons, so basically managing the scaling of the VMs that are in the firewall cluster, or using features that wouldn't be available with the managed solution, these are all reasons why we would go to that model. Another reason as well, but that's more related to routing, is that in Azure we have limits, and we have limits in number of routes, one of them being 1,000 prefixes advertised from Azure to on-prem over express route. So if we run individual hub and spoke topologies in a region, that's okay. But with virtual WAN, and because of the inter-hub connectivity, the number of prefixes in the virtual WAN environment is growing and growing. And so we are at risk of hitting that 1K limit. And having that transit vNet with the NVA and with the spokes cascaded behind that transit vNet allows to actually do route aggregation, because the spokes are not attached anymore to the vHUB. Their ranges will not get automatically learned and propagated by the virtual hub to the branches and to other regions. And for that, to actually have the spokes still known by the vWAN environment, we need to add a static route that we configure in the connection. And that can cover, instead of each spoke range individually, we would, for example, configure a static route covering the supernet of these spokes, with next stop being the firewall NVA in the transit vNet. So we will see with Mace later more in detail how that function works and how it's been evolving over the past months. But today, when you configure a static route in a vNet connection, and here it would be on the vNet connection between the vHUB and the transit vNet, that static route gets propagated in the entire virtual WAN environment, so down to the branches and also to the other virtual WAN regions, up to the spokes and the remote branches. And anything I've missed, Nehali, on that scenario?
No, I think you got it. You got it all. I think just to kind of emphasize that, for all the reasons Cynthia mentioned, with this design is still relevant, right? So that takes us to the point about, BGP endpoint and firewall NVAs, Cynthia. So.
Yeah, right. So today with Virtual WAN, we also have a feature that is called BGP endpoint. And basically, it's the ability for the virtual hub to have a BGP session with an NVA in a spoke. So this is something that we could be doing with the firewall NVAs in that transit vNet. However, BGP endpoint is not the great use case today with firewall NVAs, because we don't yet support the next stop IP feature in the virtual hub that would allow to set the next stop to the ILB of the firewall NVAs in that transit vNet, which would then guarantee symmetry of traffic, etc. So we can do that, but it comes if we are running active instances in the transit vNet for the firewall solution, then BGP endpoint is not the best solution.
Right, and that takes us to the that takes us to the flows, Cynthia.
Yeah. So yeah, let's see what happens. So local vNet to vNet and also inter region vNet to vNet. So that obviously is inspected. So we get double inspection when doing vNet to vNet inter-region. Any local branch to vNet will be inspected as well. Same for inter-region. We would get the inspection in the region where the spoke vNets are sitting. But in this scenario, because the firewall solution is one level above the virtual hub, we can still have branch to branch if branch to branch is enabled, but branch to branch inspection will not happen. So this means relying on on-prem solutions for inspection. And again, we've mentioned it already, express route to express route transit via the virtual hub, if we don't have routing intent, is not supported. So express route to express route would have to use global reach.
Right, and that's this traffic flow right at the bottom here. And you want to cover the north-south?
Yeah, sorry, yeah, forgot about that one. So just as we had internet connectivity when the firewall was in the hub, well, we still have internet connectivity here for all the spokes, and even we could even attract the branches to outbound via that solution, again, by having the 00 advertised down to the branches and having that default route propagation activated on the branch connection for which we want the default route to be advertised to. And again, no propagation of the default route inter-region. So that's a common statement for all virtual WAN scenarios.
Right. Juan, you have a question?
Yeah, really quick. Can you comment on the status of the BGP peering feature with v1HUB? I know a while back it was in preview, but I checked the documentation yesterday. I didn't see a note that it was in preview. Is it now generally available?
The BGP endpoint feature?
Yeah, the feature that allows you to peer an MBA via BGP to the v1HUB.
Yeah, that's been GA for some time now.
Okay, perfect. Thank you.
Okay, great discussions and good questions. So, Cynthia, I think we're ready to kind of now dive into the SD-WAN scenarios.
Yeah.
Now, I would call these scenarios true popcorn time for everybody. There are 3 scenarios that we are going to go through. One is where we're going to have an SD-WAN NVA in the hub. So, we would have the appliance in the hub. Then we're going to have one scenario with routing intent with unmanaged NVA in the spoke and BGP endpoint, right? And the third one is, of course, the best of both, where we have routing intent and managed SD-WAN NVA in 2 different distinct hubs. So security and SD-WAN in the 2 distinct hubs. So with that, Cynthia, I'm going to just bear with me for a second. I'm going to set this up for you. So remove the spokes here and remove the branches here. And to remove the global reach here as well. So remove branches, and I want to keep the spokes for you here.
We have a naked virtual WAN.
Yeah, so Cynthia, if you want to, I know you have 3 options. So you can start with the one where we have the SD-WAN appliance right in the vHUB.
Yeah. So we've seen already some of the advantages of virtual WAN, and one of them is the ability to have SD-WAN overlay extended up to the Azure environment into the virtual hub. So this is kind of a way to give an Azure native experience for SD-WAN for SD-WAN branch integration. And so yeah, here we would have like what would be an SD-WAN hub or an SD-WAN cluster deployed as a managed offer inside the virtual hub. And then SD-WAN branches would have then their SD-WAN tunnels built to that central cluster in the virtual hub. And making these branches and the SD-WAN overlay entirely part of the virtual WAN environment. So deployment, the fact that it's a managed deployment means customers don't have to worry about the underlying VMs. BGP peering is built between the virtual hub and that SD-WAN appliance, and in return, the entire SD-WAN environment will know about the SD-WAN branches and the SD-WAN prefixes in the overlay and where they're injected from. So should it be via the SD-WAN cluster in region A or the SD-WAN cluster in region B for the branches connected on the right. And so basically it allows to add SD-WAN and SD-WAN branches to the list of branches supported in virtual WAN. And as we will see later, this can offer some great advantage in MPLS to SD-WAN migration scenarios, for example. Anything I've missed, Nihali?
No, I think great points. Just want to emphasize that essentially it sort of extends this SD-WAN into Azure, right?
Yeah, exactly.
And we're ready for the flows if you are, or anything else?
Yeah, go ahead with the flows. And so the SD-WAN cluster deployed in a managed way inside the virtual hub becomes the entry point for any flows initiated from the SD-WAN branches, either to the vNET or to the native branches like express route or site-to-site. But it could also be directed to the SD-WAN hub in the other region to reach SD-WAN branches that would be on another continent, for example, or remote branches or remote vNETs as well.
And Cynthia, the multiple SD-WAN deployment, do you want to talk about that, having multiple SD-WAN deployment in the same hub?
Yeah, good point, and thanks for reminding me that. So again, something to check with your SD-WAN vendor, but it's possible to have multiple SD-WAN deployments inside the same vHUB. So we said we can't always combine SD-WAN NVAs with firewall NVAs, but here what is possible to do is to have, for example, two SD-WAN deployments of the same technology inside the same hub. And the reason why would a customer do that? Well, it could be for scaling purposes to increase the capacity of the SD-WAN cluster built in Azure. We do two deployments from the point of view of Azure, but then on the SD-WAN orchestrator, that could be gathered into a single hub, for example, making it more performant, or be able so it can address higher bandwidth, for example.
Great point. Looks like Anton has his hand up. Anton.
Yeah.
Yeah, Cynthia, what would be the advantage of deploying the SD-WAN appliance in the hub versus deploying it in the spoke vNet and terminating SD-WAN connections in the spoke vNet?
Well, good question. And that's, I think, our next scenario. Yeah, definitely some advantages to one or the other solution. Maybe we can discuss them when we are in the next scenario, if that's okay.
Yep, please go ahead.
Yeah. But again, here we have, okay, we are happy because we now have the SD-WAN overlay integrated into Azure, but here we don't have any firewall solution anymore because important to remember today, and I'm not sure we've said it clearly before, inside the same virtual hub, we can have a managed SD-WAN solution deployed, or we can have a managed firewall solution deployed, but we can't have both deployed in the same hub. So, for example, we couldn't have an SD-WAN NVA deployment along a managed firewall NVA deployment in the same hub. So obviously, this brings some consideration when a customer wants security inspection in Azure. Forgot to mention one thing. So yeah, indeed, we can't have SD-WAN managed NVA in the hub with third-party firewall NVAs or firewall SaaS solution in the hub. But we can have the SD-WAN NVA with Azure Firewall. So Azure Firewall can be combined with a third-party NVA deployment, but we can't have two third-party deployment where one is for connectivity, SD-WAN connectivity, and the other is for security.
That's the stage for the indirect spoke model.
Thanks,
with
Nihali.
firewall. Yeah.
Exactly. So how would a customer do if what he's looking for is for the managed SD-WAN NVA experience in virtual WAN, but still looking for some inspection? Well, the design we're seeing here, it's similar to the indirect spoke model we've discussed before, except that here we have a managed NVA inside the hub, but the idea is exactly the same. So we use that firewall solution in the transit vNET. So Azure Firewall or any third-party security solution can be deployed in here, and we would use that for inspection. And so if we look at the flows, again, similar to what we've seen before. So maybe just to highlight that with this design, again, branch to branch, including SD-WAN to SD-WAN, interregion, etc., wouldn't be inspected, but also SD-WAN to MPLS or SD-WAN to site, we wouldn't get any inspection for this kind of traffic. And again, if this is required, it would have to rely on an on-prem solution. But then for the other flows, we kind of find again what we've discussed already before for the indirect spoke architecture, where branch to vNET or vNET to vNET gets inspected by that firewall. And likewise, when we do inter-region, we will have that double inspection for vNET to vNET inter-region.
It's the double
exactly
inspection.
like that.
Right.
Yeah.
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 Awesome. Anything else before we go to, I think that's the option that Anton was talking about. I think we're ready for that one. Let me set it up for you, Cynthia, here. So we
Yeah, and this is the perfect transition to Anton's question. So another way to keep the inspection inside the virtual hub and still have SD-WAN connectivity with virtual WAN is to leverage the BGP endpoint feature. So again, because we can't have SD-WAN and the third-party security solution inside the hub, inside the same hub. So that's a common architecture we see across some customers, where the SD-WAN deployment is not done in a managed way anymore, but instead It's a manual deployment inside a spoke. And we leverage the BGP endpoint feature, so the peering of each of the SD-WAN NVA instances with the virtual hub to automatically import all the SD-WAN prefixes inside the virtual hub, where they would then get propagated to remote hubs and to branches, etc. So that's another great way to integrate an SD-WAN overlay inside a virtual WAN environment in which we have routing intent. And so compared to the first solution, here we again get that central inspection of the firewall for all the flows. But because now the SD-WAN NVA is extracted, the SD-WAN NVAs are extracted from the virtual hub and they are not managed anymore. It means for a customer to go over the manual deployment. So again, deploying the VMs, deploying the scaling, etc. So we don't have that managed experience anymore. Still, because we have BGP endpoint, it's not that complex, and we still get that like Azure native experience in that the SD-WAN branches would be fully part of the virtual WAN ecosystem. Anything I've missed, Nehali?
No, I think you got it. Yeah, so unlike the firewall NVAs, this is a good use case of BGP endpoint, right, with the SD-WAN NVAs. And I think we're ready for the flows.
Yeah. So here, as opposed to the previous scenarios, any traffic coming from the SD-WAN branches would be inspected because, again, we use the central inspection provided by routing intent. And so any SD-WAN branch to SD-WAN branch or other branch would be either single inspected or double inspected, depending on whether the flows are local to a region or inter-region.
Yeah, all dynamic routing here.
Yeah. And anything else we have for this scenario?
Nope, I think we're ready to go on to the next one.
Yeah.
So here, let me set this up for you. Yeah, so this is where.
Yeah.
Yep.
So again, the driver of this architecture is because today we can't combine SD-WAN NVAs, managed SD-WAN NVAs and managed third-party firewall solution in the same hub. So again, not talking about Azure Firewall, but really third-party security solutions. But what if we want the managed experience for both the security solution and the SD-WAN solution? Well, that's possible. And Nehali, I let you show how we would do that. And this, but this actually requires a second virtual hub deployment in the same region. So we would have a duo of virtual hub, one managing the SD-WAN connectivity and one managing the inspection. So we would have, for example, on the left, the vHUB, the SD-WAN vHUB, where we can have the managed SD-WAN deployment that brings in the SD-WAN overlay into Azure. And then we keep that other secured hub with routing intent enabled, and they're both connected. But because we're in virtual WAN, we not only have this inter-hub connectivity, and virtual WAN is actually any-to-any, and we end up with a full mesh of all these different hubs, so security hubs and SD-WAN hubs. For that, we can now, I think, go over how the flows would work, because it's bit more complex than what we had until now, where we only had a single inter-region link.
Yeah, so we can start with the branch to spoke
Exactly,
ones.
yeah.
Yeah.
So SD1 to vNet local would first enter the SD1 hub and then move over to the routing intent hub up to the spokes. And then inter-region, it would be the same. We would, but instead of going to the local routing intent hub, we would go to the remote routing intent hub. And then if we do, yeah, exactly. SD1 branch to SD1 branch, that one would switch directly from one SD1 vHUB to the other remote SD1 vHUB. And so for that flow, we wouldn't have any inspection. So the SD1 overlay is not like an entire overlay because we have one part on the left and one part of the right, but still could be something acceptable from a point of view of a customer because it's still the same branches leveraging the same SD1 technologies on each branch. And then what happens if we have other branches than SD1? Thank you, Nihali. So a first way to connect these branches would be to leverage the gateways inside the routing intent hub. And so this way, SD1 branch to express route or site-to-site connectivity would again transit from the SD1 hub via the routing intent hub and down to the branches. So here we would get that inspection again between, like, let's say, an SD1 overlay and then the MPLS network of a customer or a data center or some VPN site-to-site connections. And likewise with the remote SD1 branch to branch, yeah. And yeah, if for any reason branch-to-branch inspection is not required because a customer already has a firewall solution for his SD1 environment or on his data center, or if the site-to-site connectivity already comes with a firewall on site, we could also leverage the gateways inside the SD1 hub. So we don't use the gateways of the virtual hub enabled with routing intent anymore. We use the gateways inside the SD1 hub, and this way we intentionally bypass the firewall for all the branch-to-branch flows. But still, we would get inspection from the SD1 branches or from any express route or site-to-site branch up to the vNET environment, up to the Azure environment. Yeah, John, you have a question?
Yeah, so my question is actually in the previous diagram where is it possible to bypass? Yeah, so the main use case here is that is it possible to have the site-to-site branch from the left branch connected to the right branch, right, via the SD-WAN? Are we able to use technology available to us to route that traffic to the firewall for compliance reasons? So instead of having the branch connect directly to the branch from the left connect directly to the branch to the right, is it possible to manipulate the route table to force the traffic between these branch connectivity to the firewall inside the hub? It's just if you can, yeah, just yeah, so as an option, so this right here, this blue line right here. So I'm just thinking if there's a way to force that traffic to go via the vWAN hub with the firewall inside, so that we can at least inspect that traffic.
So I'm not sure about my answer, but I'm thinking if playing with the association and propagation parameters of vNet connections, and instead of redistributing, for example, I'm thinking, instead of doing a redistribution towards the default label, we could selectively redistribute towards the secured hubs. But I'm not sure about that, and I would love if any of my GBB colleague or other someone else on the call had something to comment about that possibility.
What I have in mind is using a UDR. Maybe there is a route table that we can manipulate without the routing intent in the vWAN hub. That can be one way, or maybe like BGP, maybe as a way to advertise. So set the route preferences.
Yeah, but you couldn't have a next stop set to like the remote hub, the remote firewall. Sorry, firewall in the remote hub.
That's true.
Martin, I think you have your hand up.
Yeah, thank you. I think you could do some things with BGP, but you would run into asymmetry if you were going cross region, because you probably end up only going through one of the firewalls. So you'd have to do something more extensive, maybe like a VXLAN between the firewalls directly so that they could route between each other or something. I think it's theoretically possible, but it'd be a lot of testing and design work involved to make it function, I think.
I'm not sure you can build a VXLAN tunnels between the firewalls inside the hub.
Okay, yeah, I haven't tried that. I don't know.
Yeah, but yeah, good point. I'll probably take that offline and get back to you on that.
Sounds good. Yeah, thank you. It's something that I can also help test as well. So thank you.
Thanks, John. Yeah, so with that, Cynthia, I think we're ready for the last layer here before we hand it to Maze and Shruti. So this is the one. Yeah, so this is the scenario where we are going to show the migration scenario from MPLS to SD-WAN. And this is a scenario where customer already has an existing MPLS deployed, and an express route is connected using this any to any IP VPN. So we want to run through this one, Cynthia.
Yeah, sure. Yeah, so with this model, with this express route model, from an MPLS network point of view, Azure is connected and would appear as any other MPLS branch. And so the use case we want to share here, is about. I've talked at the beginning about my experience in having customers who want to migrate from their legacy network to SD-WAN. Well, this is the kind of scenario they could be using. So during a migration, there is a transition phase where a site which was initially connected to MPLS would switch to SD-WAN. But obviously, now that this site is connected to SD-WAN, connectivity to all the sites not migrated yet on the MPLS site is still mandatory for the customer network to function correctly. And so a way to do that for customers would be to leverage an on-prem MPLS to SD-WAN gateway, meaning additional infrastructure required for that function. But what we see is that when customers are moving from MPLS to SD-WAN, it's not only about changing the technology on-prem, it's because they have this cloud-first approach where they want to move more and more stuff into Azure. And so having that additional infrastructure deployed on-prem for the MPLS to SD-WAN gateway doesn't make really sense. So one of the options is to leverage virtual WAN and the branch-to-branch connectivity we've covered, and which is one of the features of virtual WAN, to actually use a way to extend the SD-WAN overlay into Azure, into virtual WAN. So using managed NVA or BGP endpoint, any solution would work. And leverage the fact that we can create a transit using virtual WAN and transit from SD-WAN to MPLS. So that's actually a great way to maintain connectivity between any new SD-WAN deployed branch with legacy MPLS branches that haven't migrated yet. A few considerations to take with that design is that today we are limited in the number of routes we can send down the express route circuit. So this limit today is 1,000. So imagine you have a big customer that already has thousands of prefixes that are slowly migrating from MPLS to SD-WAN. At some point, you're at risk of exceeding that 1K limit down to MPLS. So a few options to fix that issue is it's possible to do aggregation at the SD-WAN NVA appliance level, or we could leverage roadmaps, which is a feature currently in preview, but that is expected to GA in the coming weeks, to actually summarize the SD-WAN routes before sending them down to express route. So yeah, first attention point. And then we have some pros and cons as well. So obviously, having that constant flow from SD-WAN to MPLS or from MPLS to SD-WAN has some costs because the outbound traffic from Azure is charged. However, because we're talking about a migration, so something limited in time, it can still be a valid scenario, especially when compared to maintaining or building that on-prem infrastructure that would be required at the time of the migration. And then one of the advantages is that by doing so, it's completely aligned with the move to cloud strategy that many customers are looking for. So with getting rid of basically on-prem DC infrastructure. And anything I've missed or anything you'd like to add, Nehali?
No, I think you've got this covered, Cynthia. I don't see any raised hands. So I think we're ready to now transition to Shruti. Shruti, when you are ready, you can share your screen. Shruti is going to share a scenario about building redundancy between AVS, Azure VMware Solution, and on-prem using some third-party appliances.
Perfect. Thank you,
Shruti, over
Nehali.
to you.
Did you guys see my screen?
Yep.
All right, perfect. So I am not using Draw.io. So I have used Excalidraw to just draw certain scenarios that I was recently working on to show you how we did. We came up with the solution for a customer. So before I go to the solution, I just want to run through what did they have before they moved to this solution. This customer, they were already on virtual WAN, which Nehali, Cynthia have been talking for a bit. They're already on virtual WAN. They were using Azure Firewall, spokes linked to it, but it was not a single hub virtual WAN. They had multiple virtual WAN. So they had, for two regions that they had Canada Central and Canada East, they had two different virtual WANs with vHUBs in each of them. So the challenge when you have a setup like that is it's not a mesh. So let's talk about what was happening. So they had their spokes linked to vHUB 1, which is in Canada Central, and AVS Canada that came up with, they linked it to their existing vHUB 1 in Canada Central. They also had Canada East AVS, which they linked it to Canada Central because this is all their primary. So they wanted covered in case something happened to the AVS environment. They wanted to have that backup connectivity to the AVS Canada Central. They were not really working on Canada East but quickly realized they had now the environment in Canada East was expanding, which was a whole different virtual WAN with spokes connected. These spokes had no connectivity to these because they're different virtual WANs. So the solution they came up with was, okay, let's build site-to-site tunnels between these two virtual WANs. And because they use same ASNs, both virtual WANs, they could not use BGP. So they had to build static tunnels to establish connectivity between the spokes. They were not linking express routes to these vHUBs, and hence they were not hairpinning over express route. All in all, they had the connectivity. Things were working, but they came to us with an idea to improve the environment because they were scaling on the AVS. They wanted to have backup connectivity that could scale. They had good path. They had connectivity across the spokes, which was not dependent on VPN. So we started working on that. So let me just move to their requirements and the solution that we provided and why. So one of the requirements was there should be inspection across the spokes. Second was, oh, one thing to add, they were using Azure Firewall, but as part of their multi-cloud strategy, they wanted to use Fortinet. They wanted to use it on all of their cloud environment, Azure, outside Azure. They wanted to use a central, same flavor of firewall, so they decided to use Fortinet. They were already using Versa SD-WAN solution. So the requirements was spoke-to-spoke connectivity should happen through, should get inspected through the firewall. AVS in Canada Central should have connectivity to on-prem through SD-WAN. But at the same time, if something happens to this SD-WAN in Canada Central, it's not available, then they need to have connectivity for this AVS through the SD-WAN in Canada East. I will talk about the path in a bit, but the idea was they wanted to make sure there is connectivity like this in case of a failure of the SD-WAN appliance. And they absolutely wanted to have the spoke-to-spoke connectivity with inspection across the hubs. And if you see in this design, Fortinet is sitting outside the vHUB. That is because one other requirement that they had was they need to be able to DNAT the traffic that comes in inbound from internet destined to source spokes or AVS. They wanted the ability to DNAT, which today is available in preview in vHUB, but they wanted a GA feature when we were designing this, so we had to put it outside of vHUB. So, okay, let's start talking about the setup. So one of the recommendations that we made is instead of having two different virtual WAN, let's now combine it all to a single virtual WAN with multiple hubs. So one in Canada Central, one in Canada East. And since Fortinet, they wanted DNAT, Fortinet was outside in a spoke. SD-WAN was already built and connected, so they didn't want to take the pain of moving it to the vHUB. So we let it be outside the vHUB with BGP endpoint. So they had BGP running to exchange the on-prem routes down to vHUB. And the spokes here were behind the Fortinet so that they get the inspection that they need. At the same time, there were summary routes for the spokes added on the vHUB with static route propagation enabled, so the routes are exchanged across the vHUBs. So now spoke 3 here has a UDR to go to Fortinet, and now Fortinet knows to get to spoke 1, this is the path I need to use. Similarly for spoke 1 for the return traffic. For the two AVSs to talk to each other, there is also global reach. They have their replication and sync going on, so they have global reach because AVS, for anybody who is not aware of this term, this is Azure's VMware platform. So we bare metal service that we offer to the customer where they can bring their VMware environment and host. AVS comes with an inbuilt express route circuit, which we host on. So typically, if you know express route, we use Microsoft Edge routers. We just call these routers dedicated Microsoft Edge routers. So there are DMSEs. So what we've done here is we have created global reach between those two DMSE circuits. So this is a global reach between them. And each of these AVS now is linked to its own region. Once we have this set up, let's talk about the traffic flows. Now, Spoke, to get to internet, it goes through Fortinet out. AVS, because I have static routes added here, to get to internet, it goes this path. Some question might come, okay, why don't we use BGP here too? Why am I using static routes? To explain that, it goes back to Cynthia's point that she made earlier. I have an active Fortinet here. I cannot do BGP because if I do BGP, then we don't have the next hop IP feature. So what will happen is I'm risking asymmetric routing at that point. So traffic comes in through one instance of Fortinet and the return might go through another instance, causing asymmetry. That's the reason. For SD-WAN, I am using BGP, but for Fortinet, I am not using BGP endpoint. So that's why we have the static route added to each of the vHUBs. Now, from Spoke, we spoke about Spoke goes out to internet like this. Spoke-to-Spoke connectivity within the same vHUB is through the Fortinet. It does not really ever make it to the vHUB. It just bounces off the Fortinet. And for hub-to-hub, it goes through each vHUB and each of the Fortinets across the region. For AVS, now, for Spoke connectivity, again, the same path, go through the Fortinet, hub, Fortinet, and Spoke. For on-prem connectivity, it now goes through SD-WAN down to on-premise. What happens when this SD-WAN connectivity is lost? If this goes out of the picture, there are two things that would happen. One is, though vHUB traditionally will learn the routes from this SD-WAN to remote vHUB, but this AVS will also learn the route to on-premise, this path through global reach. So now AVS has to pick, oh, I have this route coming over over remote hub, but I also have the route coming over global reach. Which one will it pick? It will pick global reach. The reason is when the routes are learned over SD-WAN through remote hub, we prepend it additionally with 2 ASNs. So when AVS and the routes that come over global reach, this is an IBGP connection. So there is no additional ASNs added. So when AVS circuit looks at the path, it says, okay, this is a much longer path than what I have here. So I'm going to pick this. So you will see when the traffic routes for the secondary path, in case of Canada Central SD-WAN failure, it would be through this. Let's spend a minute on the return traffic too. So we have a path, we know how the traffic routes, I said it's through global reach, not hub to hub. What will happen in the return path? In the return path, you will see, oh, again, vHUB has a decision to make. It'll see, I am learning these AVS prefixes through the remote vHUB, but I'm also learning it through global reach. Now, I already explained that when you have it through remote vHUB, we do the prepend. So the path would look 65520, 65520 plus additional 12076 and the AVS ASN to give you a gist, not go into the weeds there. But at the same time, when the route is advertised through global reach towards the gateway, we also do prepends there, because we always want global reach to be less preferred. That was the idea. So, but eventually in this specific scenario, what will happen is you will have exact same path over remote and global reach. When there is a tie in the AS path length between remote hub and express route is always the preferred path, which is good in this scenario because we are going to maintain the symmetry. The traffic comes in from here, the traffic will also return from the same path. So this kind of helps us maintain the symmetry of the traffic path. And just to add one more thing, hub routing preference is a setting that you have to choose or make sure it says AS path, right? Because in this specific scenario, what will happen is you will also learn these, actually, no, this is in this scenario, it is fine. But even if you choose AS path here, the return path that I said, it will always pick express route because of the route preference, which is where express route always wins. Yes, go ahead. I see there's a question.
Yeah, thank you. So the AS path prepending you're doing this is the default AS path prepending, or are you manipulating it?
No, so that's the thing. We really cannot manipulate anything on the AVS or express route side. So whatever prepends that I'm talking about, it's out of the box.
Okay, thank you.
And one more thing. So you might be thinking, okay, this is pretty straightforward. What is the big deal about having these redundant paths? So I just want to take a minute and highlight. It can be a little tricky if it were not SD-WAN and express route. So I'm not going through the whole architecture here, but what I'll touch on is, let's just assume this is same as the earlier path, but let's look at this piece. So this is same your AVS, and what I said, the AVS DMSCs. On-premise now is not using SD-WAN, but using express route to connect to AVS. So now you have global reach with AVS, right? This ties back to what Cynthia Nehali explained later, that the express route are not transitive. So just because both these circuits are linked to this vHUB, that does not mean they can talk to each other. They're not transitive. If you want them to talk to each other, you have to have global reach, or one other option, which is a little more work, which we can talk about that later. But yes, so you need to have global reach here. What if this global reach goes down? What if this path goes down? Let's say you also have an express route in the second region, right? Which is also connected via global reach. The catch here is now AVS has identical routes from two paths. This will end up doing ECMP, which is not what we want. We don't want it to do that. So what we do is, okay, let's go ahead and prepend. Now this is not out of the box. We on-prem has to do prepend and make this path longer. Great. So now AVS on East exactly knows, hey, this is my path, this is my preferred path, and this is secondary. But what we completely forgot about in this picture is there is another region which also needs primary and secondary. So if you're using the same circuit, you will end up having to link both of them. But now because you prepended what is coming to west, you have forever broken this connection. So this from west will always go through east because you prepended this path. So the ideal solution in this scenario would be to do a prepend towards west, considering picking up whichever is more critical or primary for you, and then use automation in case of a failure in west region to create that global reach at that point. This was quick high-level information. That's about it. Any questions, feel free to ask.
Rudy, just a quick question. If you go to the left side of the diagram, when you mentioned that you had to use static routes instead of BGP on the Fortinet, could you use load balancers instead and have that kind of symmetry, because the ILB would track the session and the instance of the Fortinet in that spoke VNet?
You have to use ILB here, no matter what. That was the whole point, right? So in Fortinet, if you had, when you do peering with vHUB, you are really peering the Fortinet instances. You're not peering the load balancer. So that's where asymmetry comes into the picture, that, okay, this vHUB router is learning the routes from each of those Fortinet instances, right? And both are active. So they're sending the same route, so it'll pick whatever path. And the problem is, when it is BGP, we don't have that next hop IP feature to manipulate it to say, hey, the next hop is not the FortiGate instance, but the load balancer instance. That's the problem. Yes. So that's why you need static routes where you can say next hop is the load balancer, not your instance. So that the whole, what you're talking about, right? So that load balancer can maintain the symmetry. Yes.
Makes sense. Thank you. Thanks for clarifying that.
Okay. Great presentation, Shruti. Thank you.
Thanks, Nehali.
Yep. So I think I know we're going over, but we have an excellent presentation ready with Maze. So I'm going to have her continue. So Maze, please go ahead with your presentation and share your screen when you're ready.
Sure, thank you. Hi, let me know if you guys see my screen.
Yes, we can see it, Maze.
Okay, so in this scenario here, I just want to highlight the benefits of, the recently when GA feature, which is static route propagation, and how this is helping us, let's say, in building a high availability MVAs, when the MVAs are built in connected spoke instead inside of the vHUB. Because as have been mentioned by the vendors before in different sessions and today by Cynthia, where some features maybe not supported when the MVA, let's say Fortinet or Palo Alto inside the virtual hub versus when it's in a vNET. So if a solution requires some feature inspection that's missing inside the vHUB, or maybe like bandwidth requirement missed inside the vHUB, then the other option for the customer is to again just deploy the MVAs inside a vNet connected to the vHUB. This also applies to Azure Firewall, by the way. Same thing. There are some things like IP prefix today is not supported with Azure Firewall inside the vHUB, so the customer will choose to deploy it in a vNet. Now, what's going on with this design? As have been mentioned in different scenarios as well, NextHub IP feature with a route server inside, or let's say the router inside the virtual hub is not supported today. And how is that significant? Because with the NextHub IP, we can manipulate saying who's the next hub. And instead of each MVA peering directly with the route server inside the vHUB, where return traffic can go to any MVA now, and we lose this traffic symmetry. With the next hub IP, I will send everything to the load balancer IP to maintain the session. So what the customer was doing until static route propagation came in, and by the way, next hub is also on the way, but let's say because now this is already GA, what can this do? So I will just go over first the problem we were seeing before. So basically, the customer will define a static route saying, hey, I have those spokes. I will focus on spoke 1 to spoke X, but the same concept apply to spoke 1 and spoke Y here on the other region. So I have two regions, East US, Central US. I have two express route circuit and gateways. This is the circuit and these are the gateways. These are connected with a bow tie for redundancy from each region from on-prem side. So what will happen is here, the customer will define a default route table before this feature was there, saying, hey, I have a summary route for my spokes here, 10.1. We'll make it /16 go to load balancer 1, right? And we'll define the same on the other side to make sure they will be able to reach from spoke 1 to spoke Y all the way to the spoke 1 and spoke X here. But what's happening here is that this express route circuit that's doing the bow tie type of connection was learning two equal paths to the same prefix here, right? So if I'm coming from East US, I can go this path and I can go this path, right? And this will create an optimal path. And as we see here, it's same ASN, Express Route Gateway, sending the route down here with the 65515. This is the Express Route Gateway ASNs. Same thing here. So again, this will cause an optimal path and some latency here. So what was the workaround before the static route propagation? The workaround was, okay, let me go to the default route table and have the more specific route to my local region. So the 10.1.16, we split it into 2/17, that 10.1.0/17 and 10.1.28/17. This way, I can make sure that my local region will always prefer this path over going this path, and this path will be only if there is like some type of failover or anything. Same thing applies if I'm coming central US. Now, I can make sure I'm going this path instead of going on the top here or maybe here, right? So splitting to two more specific prefix will help me to choose the optimal path always, but maybe it's not like, as easy as you're seeing here. So when static route propagation came into the picture, how did that change configuring the static route? I will configure the static route only at the vNET connection level, which is here. I don't have to do anything at the default route table. And I will enable this feature. And I will have my regular summary route, which is 10.1/16, let's say, which is covering, let's say, all my prefixes here. What will happen is this route will be advertised down like this, 10.1/16 with ASN 65515, right? But it will also be advertised to the other vHUB, and we will prepend with a 65520, 65520, because this is always be added with any inter-region or inter-vHUB learned route. So it will come down here, prepended. So I don't have to worry about this. And the same thing on this side. My central US, if it wants to go to the spoke 1 to spoke X, it will always prefer the shorter AS path versus the one that's coming from the other gateway. So yeah, that's about it.
Thanks, Miss. Awesome
Sure.
use case. So this is G8 now then?
Yes, this is GA. Yes. And also, besides, like, you will get optimal path. You don't have to worry about, configuring the same route over in every single vHUB. It will be inject those routes already in every single vHUB with the right prepended, path.
But if for some reason you wouldn't want that route to propagate to all the remote hubs, then all you have to do is disable the propagate static route feature and then have it enabled as you shown using the default route table on the specific hub where you want that route.
Yes, correct.
Excellent. Thanks, Maze. I don't see any hands raised. We are going to close out this session with a sneak peek at the upcoming sessions in this series. And again, this series is about partner solutions in vWAN. Let me show you these different partner solutions that we have. Again, these are taken right from Azure documentation, and if you click on it, it will take you right to the documentation. So again, the breakdown of partner solutions in vWAN is based on security partners. Here you can see a list of supported partners, SD-WAN partners. Some of them are dual role, and then of course Palo Alto SaaS offering is unique in its own way. It's not NVA, it's a SaaS offering. So, at a high level, to think about, if you want to look at it, different partner solutions, you can think of it as security or firewall solution versus SD-WAN connectivity solution, managed versus unmanaged solution, SaaS versus NVA, and dual role. Right? So today we have all of these partners with us. All of these partners are listed over here. And in the upcoming session, we will be having individual sessions with these partners. And let me, from an architecture perspective and a placement perspective, let me show you all of these different scenarios one by one. So let's look at the native solution first. And this is the Azure firewall with routing intent. And that's the native solution. And then we have managed SD-WAN, right? So this is right in the vHUB and it's a managed solution. And this is unmanaged SD-WAN appliance. And then we have the security NVA, which is right in the vHUB. So this is also managed. And then we have unmanaged security solution right here. And then finally, we have the SaaS solution. So Cynthia, I know there are some different callouts when it comes to combining these solutions together. Anything you want to add to this?
Sure, thank you, Nihali. So today, for example, it's possible to have in the same virtual hub Azure Firewall and the third-party managed solution, whether for security inspection or SD-WAN connectivity. So we could have here, as represented, an Azure Firewall plus an SD-WAN NVA integrating an SD-WAN overlay into the vHUB environment directly. Another solution could be to have Azure Firewall with this time a third-party security solution with managed NVAs like Checkpoint or Firewall. Or we could also have Azure Firewall inside the vHUB combined with the Palo Alto SaaS solution, as represented in region 2. So basically, coupling security solution is supported, and one of the reasons to do that would be, for example, to manage private traffic protection, which is also called east-west traffic, with one solution, and then have the second solution dedicated to the internet protection.
Right, so this in this scenario, Cynthia, the spoke one can egress to the internet using this solution, and then the branch-to-branch traffic, the private traffic, could be using the third-party solution, right?
Exactly.
Good point. Okay, and
so there are possible combinations inside the same virtual hub, possible to combine managed offers. However, it's not yet supported to combine a managed third-party firewall solution and a managed SD-WAN deployment inside the same virtual hub. So here, as represented, we couldn't have both a deployment of, for example, VMware SD-WAN plus have in the same virtual hub Checkpoint or Palo Alto or Fortinet for the security solution. So that's not supported today. And this is why one of the scenarios we've covered was having a dual hub per region, one for hosting the managed SD-WAN solution, the other enabled with routing intent and using the firewall NVA or SaaS solution. And just maybe to finish, when we talk about routing intent, this means having a firewall solution inspection inside the hub. So that is what routing intent refers to. But routing intent is not mandatory for managed SD-WAN in the hub.
right, so this SD-WAN does not require routing intent, but this solution, the native firewall and the managed firewall requires routing intent.
Exactly.
Great. Thanks, Cynthia, and thank you everyone for joining us. And stay tuned for the next video in this series. It was great to have you all on this session. Thank you, Maze and Shruti, for an awesome presentation. And Cynthia, any other last closing thoughts before we drop?
No, that's all for me too. Thanks, Niali, for having organized that. And yeah, see you for the next episode.
Excellent. Thanks, everyone.